Hello everyone. Welcome to the video lecture on course 6EE 513 Electrical and Hybrid Vehicles of semester 6 of program BTech in Electrical Engineering of Rajasthan Technical University. I, Professor Praveen Sonone of Purnima College of Engineering, is taking this opportunity to deliver this online video lecture series. In today's first interaction, our objective is the student has to understand various types and overview of electric vehicles. Now let us discuss the topic, which is overview of types of EVs and their challenges. It can be classified in terms of propulsion devices or energy sources or even the energy carriers which are used as medium to transfer energy from energy sources to propulsion devices. So, based on propulsion system, EVs can be further classified as pure electric vehicles or hybrid electric vehicles. A pure electric vehicle uses electric motor as a sole device for propulsion, while an HEV uses both electric motor and IC engine for propulsion. Popularly, pure electric vehicles are also known as EVs, while HEVs are known as only HVs. If we classify the EVs on the basis of energy sources, basically energy sources, there are actually the two energy sources or energy trains. One is from the conventional energy source and another is from the battery based energy source. Considering this in mind, pure electric vehicles will be further again classified into battery electric vehicles and fuel cell electric vehicles. So an HEV uses both liquid fuel and battery as energy source, while a battery electric vehicle uses battery as a sole energy sources. On the other hand, a fuel cell electric vehicle uses both battery and fuel cell as energy sources. A similar classification can be done on the basis of energy carriers, where the energy carriers for battery is electricity, while the energy carriers for a fuel cell is hydrogen. So, four types of EVs come under the family of pure electric vehicles. They are battery electric vehicle, fuel cell electric vehicle, ultra capacitor electric vehicle, and ultra flywheel electric vehicles. In all these vehicles, the battery is a common energy source, while a BEV uses battery as sole energy source. Fuel cell electric vehicle, ultra capacitor electric vehicle, and ultra flywheel electric vehicles uses battery as a hybrid energy source. In a fuel cell electric vehicle, battery is primarily used for absorbing the regenerative power, since fuel cell is incapable of storing the renewable energy, while in ultra capacitor and ultra flywheel based EVs, batteries are required for storing energy, since ultra capacitors and ultra flywheels have very low specific energy. So, as we know, a hybrid electric vehicle uses both motor and IC engine for propulsion purposes. So, on the basis of ratio of hybridization between electric motor and IC engine, it is classified into 5 types: micro hybrid, mild hybrid, fuel hybrid, plug-in hybrid, and range extended hybrid electric vehicles. So the rating of electric motor is very low in micro hybrid vehicle and is high in REVs. On the other hand, the rating of IC engine is high in a micro hybrid, while it is low in a REV. So micro hybrid, mild hybrid, and full hybrid are clubbed and known as conventional hybrid electric vehicle, while plug-in hybrid and PHEVs and range extended hybrid, which is known as REV, are clubbed under grid-able HEVs. So the difference between these two types is that the conventional HEVs can be refueled only at the filling stations or petrol pumps, while grid-able HEVs can be refueled both electrically and and at the filling stations. So a grid double HEVs enable direct charging of battery using charging ports in addition to refueling by liquid fuels at filling stations. So the classification of all types of electric vehicles in terms of propulsion devices, energy carries and energy sources is elaborated here. So in terms of propulsion system, a hybrid electric vehicle primarily uses an engine and electric motor, while a pure electric vehicles uses solely electric motors for propulsion type. On the other hand, if we classify the EVs on the basis of energy carriers, hybrid vehicles uses either liquid fuel or electricity as energy carriers, while a pure electric vehicle uses either battery or hydrogen as energy carriers. If we classify the EVs on the basis of energy sources, you will see that hybrid vehicles uses either liquid fuel or battery as an energy source, while the pure EV uses battery and other types of energy sources as ultra capacitor, ultra flywheel and fuel cell as energy sources. Among the different types of conventional HEVs, the micro hybrid, mild hybrid and full hybrid provides and offers different types of capabilities to the system. In a micro hybrid, an ISG of around 3 to 5 kilowatt with a system voltage of 14 to 42 volts is used. Generally, it can be seen in the small motorbikes. So, the ISG supports not only the starting of IC engine, it can also support the stopping of IC engine when the vehicle is at rest. So this is known as start-stop features, which can provide very easily in the electric vehicles. So these features enable fuel economy in these vehicles, as it can also help in recovery of regenerative power available during braking. Generally, this is a low power ISG and they are connected using belt driven system. In a mild hybrid, an ISG of slightly higher rating is used. Typically 7 to 15 kilowatts can be seen with a system voltage of 100 to 150 volts. In addition to this, ISG enables not only start-stop features and regenerative braking, but it can also support the IC engine in power sharing during normal operation, which means the IC engine rating can be reduced to a little extent. In a mild hybrid, the ISG cannot support a pure electric motor. Based launching or starting of a vehicle different from the operation of a micro and mild hybrid, a full hybrid offers more versatile operation. The vehicle will operate in IC engine mode alone, an electric motor alone, or in combination of both the IC engine and motor together. It requires a complicated transmission system which is known as electronic variable transmission, which is generally a high power device of 50 to 60 kilowatt with the system voltage of 500 to 600 volts. So this device allows connection of IC engine and motor together or in a sole way to the wheels, and that allows various kinds of perception possible such as start stop, regenerative braking, power assist and also electrical launch. Means a full hybrid can start in all electric mode using an electric motor alone. Since full hybrid can work in various modes, the IC engine can now operating with high efficiency mode in optimum operation line, which is known as OOL in IC engine terminology. So what are the challenges of a typical battery electric vehicle? Let us have a small look on these challenges. The energy storage capacity of a battery electric vehicle is lower as compared to IC engine.